Hi, friends. Welcome. It's week 7. We're doing an algorithm. Today we are doing a algorithm called is palindrome, to where we are checking to see, writing an algorithm takes in a word, checks to see if it's a palindrome or not. Palindrome is a word that is spelled backwards, makes the same word. So example would be race car or madam or civic or Hannah. Before we get started, just a couple housekeeping. You have a discussion question due Sunday, please do that and make sure you're kind of keeping up with your core assignments. This week, next week, and the following week are like your sort of makeup time. This is your midterm, midpoint. So if you guys are falling behind, now is when you definitely want to do that. Cool. So let's jump in and do that. We're going to build this algorithm together because I just want to kind of make sure that we can build this together and make sure everybody's on the same page. So when I'm approaching an algorithm, I would do something called pseudocode, UDO code. And that is the process. And I know we've talked about it before, but I'll say it again, that is the process of writing out or steps before coding them. This is when we really want to think through what we're doing and we're saying, okay, what are we wanting to do? Why are we wanting to do it? And this helps us get edge cases if there are any. It helps us just sort of think through this. So what I like to do is I like to break down what the actual question is, right? So write an algorithm. So I'm going to take that as a function. So I need to write a function that takes in a word. Now, when I see this takes in or accepts, that means that it's going to have a parameter, right? With a parameter. And then it checks to see if it's a palindrome. Okay. So in just reading that, we know that we're going to write a function with a parameter. Cool. What are the things that we can do that we can check to see if it's a palindrome? So this process right here, see if it's a palindrome. And maybe we could just use some buzzwords right now to kind of get it going. But what do you guys think would be some tools that we've learned so far that we're going to need in order to do this? I guess we're even thinking, what if we're just not even using the tools part, but what are we going to do to check to see if it's a palindrome? We're just kind of thinking about how would I do that?
You said it will be you said it will be a function, right? So,
Yeah, it's a function.
um, I'm trying to think.
I guess we don't even have to, without coding, what would you do? How would you check it? If you're with your eyes trying to check to see if a palindrome or a word is a palindrome, kind of what would you do?
You will look at the letters.
Yeah, exactly. Are you just
So,
gonna look at this letter, or are you gonna compare? Are you gonna look at every third letter? How would you do that?
um, I'm thinking this is gonna kind of go towards a loop,
Mm-hmm. Exactly.
maybe.
Yeah, so we're gonna have some sort of for loop because we need to iterate through the word 100%. Again, let's just think if I were to ask you, hey, is this a palindrome? How are you going to figure that out? Now, I'm not talking about coding, just in your brain. What would you do?
But that's kind of like a brain teaser if you think about it, because you look at the word and you're just like kind of dissecting it mentally.
Yeah, so what is that? That's exactly how would you dissect it?
Um, I'm not sure.
Clarice,
You what? I'm sorry?
you say the palindrome is spelled backwards. Oh,
Hey, Jeffrey.
hello, how y'all doing?
Hey there.
Hey Jeff.
So
Okay.
the way that I would approach this, right? If you were to ask me, hey, is the word race car a palindrome? Maybe this is just how my brain works, but I would check this letter and then say, is it the same as this letter? And then I check this letter and say, is it the same as this letter? And I would kind of go through that until I get to a point where, I can say like, yes, this is a palindrome. Right? That's just like how my brain would think through that. Would anybody else have thought that?
I see what you mean.
Yeah. So we know we're gonna loop, but whenever I'm checking and seeing is this the same as this, what is the term we use there? What's the coding thing that we use there? What is that?
Is it a range?
We're gonna use it with range. But specifically, if I'm comparing this one to this one, what is that called?
You're doing a conditional?
Yeah. Yeah, I'm comparing the two, right? I have some sort of conditional statement. So I know that I'm going to loop with a range. I'm going to have a conditional statement to check. Okay. Cool. Then maybe I would say like if they match, move to next letter. If they don't match, I just need one to not match, right? I don't need to keep checking after. So then I'm going to say exit and return false. And lastly, if we get to the end of for loop, return true. Because if it at all they didn't match, we're going to exit and then return false. So if our for loop ends, that says that we never got a non-match. So then it's true. Does that make sense?
Say that one more time. If they don't match, then they'll exit return false.
Yeah. So we have this for loop, right? Where we're going to have this conditional statement and we're going to say, hey, does this matter? Does this letter match this letter? And if it does, then okay, we move on to the next set to make sure, okay, does R and R match? They do. Okay, cool. Let's move on to the next one. Does A and A match? They do. Cool. Let's move on to the next one. But let's say that I had, let's say I had the word museum. I'm going to check this one. Does M and M match? Yeah. Does U and U match? Yes. Does E and S match? No, it doesn't, right? It's not the same. Therefore, we return false. But if I get to this point and I say, Hannah, does H and H match? Yes. Does A and A? Yes. N and N? Yes. My for loop's done. And I haven't exited to say false, then I can assume and imply that it's true. Does that make sense?
Okay. Yeah.
Cool. So let's go ahead and code this out. So I'm going to say def is palindrome. Now I said that it takes in a word, so I'm going to say word. Cool. So we've done this first part. Now I need to loop through my word and check every letter. So I'm going to use range, say for I in range. And I have to pass, or I can pass some information here. First off, I want to pass where I start. I don't have to this one. This one's defaulted, but we could do that. And how do I know the end of this range? How do I know, because I want it to be able to work with race car in the same way it can work with Madam, right? And those are two different lengths. So what can I do to make it dynamic? What if I did something like this? Len of word. Because that's going to give me the number for how long the word is, right?
Can you
Remember
say
if I-
that again? Sorry.
Oh, go ahead.
Yeah, so len of word is going to give me the length or how many letters are in this word. 1, 2, 3, 4, 5. So it's going to return len of word returns to me 5.
Okay.
And so when I'm saying in range, I need this. I don't want to hard code this to 5 because race car is 1, 2, 3, 4, 5, 6, 7 letters, right? So now all of a sudden that doesn't work. But if I say something like this, doesn't matter how long the word is. I could have a super duper long word or I could have a really short word. This is just going to ebb and flow with the length of my word that I'm given.
Got it.
I
So
have a
it
question.
knows how long. Yeah, go ahead, Jeffrey.
So, is that like any word that you're given, or
Yeah, so word is what's going to be passed in. And so I'm just taking this. If this was unicorn, it'd be the length of unicorn. It's just
oh,
my parameter. Just my parameter. Okay. So now we need to check the first letter versus the second letter or the last letter, right? Or I really need to be able to keep track and now start checking my letters. Right?
So how I'm trying to think like how you would do that, like, because you're starting from both ends, right? Is how you mentioned it.
Well, we need to right now we're just doing a normal for loop. But yeah, I need to start from both ends.
Okay.
So if I said if, and in this case I said word, or no, sorry, word of I. Word is the word, and I remember in the same way that I can see an index position, I can give an index position for a list. I can do the same thing with a string. So when I say word of I or word of 0, it's going to give me whatever the first letter of that word is. So in this case, it's going to give me R. The same way that I have 0, 1, 2, 3, 4, 5, 6 as an index position. If this was a list, a string works the same way.
So the W would be a 0, the O would be a 1, the R would be a 2, and the D would be a 3. Is that correct?
That's incorrect. Word is a
Okay.
parameter. It represents whatever is passed in here. So word of I
Okay.
is not of the word word. It is of whatever we passed in.
Okay.
This could be unicorn and become unicorn of I. Again, the parameter just takes on whatever we pass into it.
Okay.
So I'm wanting to see if that equals it's comparison, so it's a double equals. Now I want the last one. How do I get the last letter? What do we think?
But the I loops through each of those words, correct?
Through each of the letters.
The
Remember?
letters, yeah.
So how would I get the last one? Because I need to compare the two, right?
Using the index. but you already used the index here.
Yeah. So what in here gets me, so let's think about this. This, if I have an index position, this is 0, 1, 2, 3, 4, 5, 6. Right? 0 through 6. What is this value going to be? Lan of word for race car.
So would it be len word I with the for index? Or I'm trying to
What
think.
if we did len of word -1?
Hmm.
But we say word of position, len of word -1. This is going to give me the number 7 because they're for race car 1, 2, 3, 4, 5, 6, 7 letters. -1 gives me 6. Right? Which is 0, 1, 2, 3, 4, 5, and 6. So it's going to give me that last one.
Okay, so say that one more time. You said word, you said equals word, which will be the word that we're passing through. Then the length of the word, so it'll be pretty much all the numbers, the amounts, I guess you can say, -1, so it can go backwards, right? So you can go
So
one letter less, I guess.
if I were to tell you, okay, let's look at just race car right now. And I said, hey, what index position is the last letter? If I wanted this last R, what would I type there? Let's say that it's word, right? Referring to word. I would say, you know, word of 6, right? I just say the word and then the index position. This way, again, whether this grows or if it's 5 or 7, doesn't matter. This gets the last value in the string. And the same thing, it would work the same way with an array, or a list. But this gets me the
Hey.
length, and then -1, which gives me 6, which is the last. Remember, length of anything is always one more greater than index position.
So
So this
that's why we,
goes,
is that why we
Mhm.
put the -1 there?
yeah, because if I
Oh.
said len of word, this is 0 through 6, len of word is 7, it's gonna say, hey, there's not a value at that position.
Yeah, because that's where it always stops. It'll stop at the following.
Yeah. So actually, I'm going to change this up a little bit. I'm going to say if it doesn't match based off of this, right? If it doesn't match, then let's go ahead and return false. And I'll wait till my for loop's done. So I make sure that I'm indented over to where now I'm on the same level as the for loop. And so this is going to iterate through, and if it's done, I can return true. But there's an error here. You guys see the error? What
You're
in this
missing
for
the
loop
else?
is, I don't need an else.
Okay.
What in this for loop, what is incrementing up? What value in this is incrementing up?
The first word, it should be the first word I.
Yeah, I specifically, right, is incrementing up. It's going from 0 to, in this case, 7 if we're talking about race car. Is
Alexa,
this, Is
Hard
this
to do.
decrementing? Is this decrementing? Meaning going down at all, or is it stagnant?
Anybody?
Guess what? Should I say stagnant?
I think stagnant, right? Because this doesn't change. I is ever changing. I is going from 0 to 1 to 2 to 3 to 4, all the way up, right? But this is always checking word of 6. Right? Because that's sort of a hard-coded thing. So if we want it to go, okay, check this R with this, the first and last letter. Okay, second letter, second last letter, third letter, third to last letter. If I wanted to do that and compare to see if it's a palindrome, what value here is incrementing up? We just said it.
Yes,
I-
it's the first word, no? Because I
Not
think
the first word, just this
the
I,
index,
right?
sorry, the index, yeah.
Yeah.
So for
So
it to, I'm sorry, well,
no,
I'm
go ahead.
thinking, I don't know if you guys agree with me, but I'm thinking maybe it should be the equals with an extra symbol. I'm trying to think of the symbol before the with the negative. I'm looking at my notes to see if I find it.
Any other ideas, Kevin, Jeffrey?
Yeah, I'm flipping my notes too.
So, okay.
What if this side we know is gonna be changing, right? Because word of I is gonna
Right,
keep changing because I is gonna keep going up, right?
right.
Well, if this is going from the first letter to the second letter, and we want to go from the last letter to the second to last letter, could we use this value on the other side? What if I did this? Now, again, this looks very intimidating, but it's actually
That's
pretty simple.
I was thinking like the minus minus because I was like, how else can we do it?
Yeah. So all word is, len of word is 7, right? Minus I minus 1. So the first case, let me get my annotation tool. I is equal to 0, right? So then it goes 7 minus 0, which is still 7 minus 1. Okay, cool. So when I is 0, it's going to get the last one, right? Cool, we compared those. Then I becomes 1. So we say word at index 1 right here. Mine does not equal len, so 7 minus 1, which is 6, minus 1 of 5, right? So if we go 0, 1, 2, 3, 4, 5. Then I becomes 2, which is right here. And then 7 minus 2 minus 1 is 4, which is this one right here. And then so on and so forth. So by using this extra, again, it looks intimidating, but all it is just very basic math of 7 minus whatever I is minus 1. And so this allows us to increment and decrement forward. Okay. Now there's one more little gotcha on this. If I get to this letter right here, or to, I've already checked this letter with this letter, this letter with this letter, this letter with this letter. do I need to, if I keep it like this, it's gonna just keep going, right? I is gonna go all the way through the length of the word. Right, so it's gonna go all the way to H. And then minus I is gonna go all the way down to this. Right, down to 0. But that's extra computational power that we're using, right? Kind of double the amount. I really just need to check. If it's got 6 letters, I need to check the first 3 with the last 3. And if those all match, then I know I don't need to double check it, right? I don't need to keep going back and forth. So what if I only wanted to check half of this? I only want to check half of this. What do you guys think I would do? What would allow us, instead of going through the entire, looping through the entire thing, to maybe loop through half of this? Or when it got to this point, I want it to stop. Got to this point, I want it to stop. To this point, I want it to stop. And then when it got here, I want it to stop. Let me reword the question. What in this for loop is controlling how far it goes? How long the for loop runs?
The parameter
Not my
is con-
parameter. My parameter, kind of. What do you mean by that? Let's explain a little bit on that. Because you're kind of right.
Because we're using the parameter word
Uh-huh.
to check, but if I'm trying to figure this out. Because that's how we're checking it, and once the word's done, it should automatically stop.
But when does it stop? What part of the code tells it to stop? What's the condition or the part of the code? What line of code tells it when it should stop running the for loop? I guess would be a better question.
Second line.
This line? Is that what you're asking? Is that what you're saying?
Yeah.
Yeah, you're exactly right. And then what part of this line is telling it when to stop?
Is it length?
Yeah, this part, right? Remember, when we're dealing with range, we have where we want to start, comma, where we want to end. And then if we wanted to, we could have a third one that is our step, so how frequent. But if we don't, it defaults in just to 1, which is all we need. So if this is where it tells us to stop, and we're saying, hey, you don't have to go through the entire thing. You only have to go through half of it. What could I change here to make it go from, in this case, 7 to 3 or 3.5 or whatever? What could I do? It's much simpler than you guys are thinking.
Let
Let
me
me.
say, teacher.
Did they say length or what?
If I have, so len of word in this case is 7. If I wanted you to find half of that, what would you do? Or say, hey, give me half of 7. How would you calculate that? I'm not talking about coding. I'm just saying if I was like, hey, what is half of 25? How would you do? What would you do?
I was gonna say divide, but we're not
Yeah.
dividing. Oh, we are?
No, that's what I'm saying. It's simpler. What would you do if I said what's half of 100? What would you do?
You'll divide it by 2.
Exactly. See, I told you it's much simpler. Much simpler than you know, programming's not always super challenging. But yeah, we just divided
You
by
know,
2.
that's actually what I was thinking. I don't know why I didn't say it earlier.
That's
I
okay.
we're
Yeah, it's
just,
hard. This is new. Go ahead, Jeffrey.
I think we're just overthinking.
Yeah, that's what I was trying to say, guys. It's much easier. Much easier. You just divide it by 2. So yeah, so what this is gonna do is remember, whenever Python or any language sees something like this, all it does is it evaluates and then plugs it in. So in this case, it's gonna take the length of the word divided by 2, and then that's what it's gonna plug in for that value. In the same way that it takes this len of word minus I minus 1, and then plugs it into word of, 6 or 5 or whatever like that. So though it might seem complicated from a very primitive level, it is just doing that calculation and then saying, okay, the result of that, and now I'm going to put that here. And so finally, we're done. We are iterating through the word. But we're only iterating through half, because if it is a palindrome, we only need to go through half because we'll already have checked it. And by that time, we'll know if it's a palindrome or not. And we're saying, hey, if word of I, so this first letter, does not equal, in this case, the first part, because I is 0, the last letter, well, then let's return false. We know that it's not a palindrome because they need to match. If that's not the case, increase I, which then decrements this by 1. And so we just keep checking. And if we ever get to a point where these are not the same, like here, then it's going to return false. But if our for loop totally runs, which means it gets all the way to the half and it hasn't exited, then we know that it's good, right? And remember, a function, once it sees a return, it automatically leaves the function, right? So we can imply and know that if it gets to line 19, it's already done my for loop and it never left. So it must be true. So I could say print is palindrome. And then maybe I'll say race car. And then I'll pull up a little terminal. Now we'll say Python 3 algo.py. Oh. So we got a little bit of an error here. Float cannot be interpreted as an integer. Nice. So this is a float, right? So I'm going to typecast it. Let's see if this works. And if not, I'll show you another way we can do this. The issue is, and I'm glad we did this with race car and not Madam, is, or Hannah, I guess would be the only one, is when we are dealing with range, we have to give it an integer on when to stop, right? But 7 divided by 2 is 3.5. That gives us a float. So I can cast it as an integer. And let's see if that works. Yep, it did. And this is going to take that. I believe it doesn't, I don't believe it goes up. I think it just goes down, which is fine. That works okay for us because we don't need it to go past that anyway. And so we get true. If I type in Hannah and I run this, I get true. But if I type in the word museum, we get false because it is not a palindrome. Hate to tell you, Estrella, your name is not a palindrome.
Funny. I didn't even know what that word was until you said it.
Palindrome? Yeah.
Me
Yep.
neither.
It sounds like I've heard it before, but I didn't know what it was.
Yeah. Well, look, we're teaching you coding and other stuff, but yeah, that is how you could write this algorithm. Are there any questions on this?
No, you taught us a new vocabulary word.
There we go.
Yeah.
Now you can tell all your friends, oh, that's a palindrome. Did you know that? And then they'll be like, whoa, are you from Star Wars or what?
That's probably where you learned it from. But as looking at the loop with the range.
Mhm.
On line 17, while we're working on a
Mhm.
conditional statement, I was going back and I was thinking minus minus the one initially before you had talked about putting the index.
Mhm.
What I'm just trying to see how.
So minus minus, remember, is just -1, right? It's short for -1. And so it'd be the same thing as if I just put -1. Which that runs into an error because this is stagnant, right? Because
Okay.
now len of word is 7 minus 1. It's always going to compare whatever letter is here to the last letter. So it's even if it goes up to, it's going to, the first one will work and then it'll go to A, but it'll still be comparing that last letter because we need something to move the needle and to decrement that. So that's where this minus I comes in.
Okay. All right. Yeah, you definitely beat us up with that division divided by 2 because we're like
I was trying to tell you, I was like, it's much easier, I promise. Much easier than you guys are making it, but yeah, cool. Any other questions on this?
You just make it look so easy when we're working on it together, but then when we have to do it on our own, I'm sure we're like all breaking our heads and Googling
Yeah.
like 1,000 things to see like what exactly are we doing wrong.
I hate to
So,
say it, but that is how you learn the best. Like I did not understand this at the beginning and I had to break my brain. And that's not like I'm like trying to break your brain. That's not obviously the goal. But yeah, it's foreign and it's new. So that is to be expected. But with that, it's just like continuing to practice that. Like try to do this on your own, even without looking at this code or watching the video. Like try now and then try tomorrow morning and be like, okay, how do I do this again? And then try to problem solve it that way, and repetitively be like, oh, because then oh, if I need the end of, I need to compare, front to back or whatever, I need to swap. That's another one we can do. Maybe next week we can like swap letters and reverse a string. And same sort of concepts apply. So we'll try that next week is to swap a string. So we'll make it to where it's backwards.
yeah, that would be pretty interesting.
So yeah, this will be your homework. It's obviously not homework, but with what we learned today, try to create a function that takes in a string and reverses the string. So A would be at the front, it'd be ALLERTSE. Or whatever the word is. So just reverse a string. So with what we learned today, try that. And then on Thursday, we'll do that next week.
Sounds good.
Okay. That
And if you
sounds
guys
pretty
get,
good.
yeah, if you guys get anything, put it in Discord so we can all see what you did.
Okay, sounds good. Sounds good. Challenging, but I'm sure we can figure it out eventually.
Yeah, you got it. No worries there. I can guarantee it. Any other questions on this?
Just to keep practicing, pretty much.
Keep practicing. That's it. Cool. Well, I'll stop the recording here.